All right, so let's jump into the review. Okay, so we started the first consumer theory slides with the idea of marginal analysis. And as I've said a few times in this course now, anytime you're dealing with something on the margins, what we're talking about is the next additional something. Okay, so marginal cost is the next additional cost, or the cost of the next additional unit. Marginal product is the output of the next additional unit of input, that kind of thing. So marginal utility would be the utility from the next additional unit of consumption. So when we're talking about marginal analysis, really we're weighing the marginal utility or the marginal benefit of consuming something versus its marginal cost. Okay. So I gave an example of Abby, and he's got the choice of how many beers to buy, and he could buy one beer and the utility was X, and the other beers, his marginal utility was Y. So, or sorry, his utility was Y, so his marginal utility for that going from one beer to two beers would be Y minus X. Okay, the additional utility he gets from consuming the next additional unit, from consuming that second beer. Okay. So it's really the change in utility from going from one beer from going from one beer to two beers. Okay. And then on the other hand, we had the marginal cost of that second beer would be the change in what he has to pay from the second beer to the first beer. So if each beer is a flat $3, his marginal cost would be $3. So the first beer was 3, second beer's total cost would be 6. So 6 minus 3 is 3. If the first beer cost $1 and the second beer cost, or the total, and two beers cost $4, his marginal cost would be $3. 4 minus 1. Okay. So what you would do is you would consume until your marginal benefit is equal to your marginal cost. As long as the marginal benefit is greater than your marginal cost, then you get more out of consuming that unit than you do then you have to pay for it, basically. Okay. So once the marginal cost is greater than the marginal benefit, then the next additional unit is going to cost you more than it's worth. Okay. So marginal analysis is all in all just a way of making a decision item by item. So the first beer, if the marginal utility or the marginal benefit is greater than the marginal cost, you consume it. The second beer's marginal benefit is greater than the marginal cost, consume it. The third beer's marginal benefit is less than the marginal cost, stop consuming. Okay, so only consume 2 beers or consume up until the point where they equalize. Okay. But as long as the marginal benefit is greater than or equal to marginal cost, you should consume that. Okay, because that just means that you have you get more out of the good than you have to pay for it. Okay. An alternative to marginal analysis is what's called a sunk cost. And basically, this is a cost that you've already paid. It's irrecoverable. But sometimes we value it emotionally, even though it might not have positive future utility. So sunk cost is a bad way of making a decision. So an example I gave for sunk cost is, let's say you're with someone who you've been with for a while, but they suck, right? Their positive marginal utility in the future is way outweighed by let's say the opportunity cost of finding someone new. Okay. Just because you spend a lot of time with them doesn't mean that it's a good relationship, right? Or another example I gave was Abby had bought all these beers. The beers went bad. He continues to eat them because he spent a lot of or drink them because he spent a lot of money on those beers. That is a bad way to make a decision. You should only make a decision if what you're going to get out of drinking that beer is better than what you're going to pay in opportunity cost or an explicit cost. Okay. So sunk cost is a bad decision-making strategy, but nonetheless, a lot of people use it. Okay, so I kind of already touched on these, but it's important to know utility. Okay, and utility is just usually it's a function like u of x is equal to some math equation here. But it doesn't have to be. It could just be a number or a variable. And really what utility is useful for is ranking different preferences. Okay, so I get 1 unit of utility for every beer that I drink. So my first beer gives me utility 1. My second beer gives me a utility of 1. And 2 total beers gives me a utility of 2. Okay. Usually we assume, so let's say this is, I don't want to use beers, let's do sandwiches. Come on. So my mouse is like frozen. Come on. All right, that's as good an S as you're getting. So that's an S for sandwiches, and this is going to be the utility of S. See, the utility of sandwiches. Usually we assume some sort of utility function that looks like this. Okay, we call this concave. Okay, you don't need to know that it's called concave, but typically a utility function is concave, and the reason is because it demonstrates diminishing marginal utility. Okay, and all that is a fancy way of saying the utility function gets flatter the further along you go. Okay, so the more sandwiches you consume, the lower the marginal utility of that sandwich. So, like the 100th sandwich to you doesn't mean as much as your first sandwich, right? So the more you consume of something, the less additional benefit that something gives you. So you can plot the marginal utility as the slope of the utility function at every point. Okay, so marginal utility here is pretty high. Marginal utility here is pretty low. Marginal utility, I'm trying to draw a tangent line, a line that touches it at only one point, but it's kind of hard to do. I'm not really sure why I chose yellow. Okay, the marginal utility here is really high. So as you get higher and higher, the slopes of the tangent lines are going to get lower and lower, meaning that your marginal utility is decreasing. Okay, the additional 0.00001th sandwich that you consume is going to get you less than that the last sandwich got you. Okay. Okay. So utility is a way of ranking preferences. Usually it's assumed based on what we know about the consumer, which we could just make up, or typically economists rely on certain utility functions that are pretty standard. Usually as long as they're this kind of shape, it's usually fair game for economists, unless we see something in the data that would say, oh, consumers actually behave like this. But by and large, we're going to make the assumption that that most utility functions are diminishing marginal utility, because that tends to be how it plays out in real life, except for maybe like addiction, which might have a solid, or addiction could even have like a marginal utility like this. I don't know. I'm not necessarily great at that particular branch of econ, which is, kind of a niche thing in itself. But in general, most economists assume diminishing marginal utility, so they'll just come up with a utility function that is concave or shaped like a curve. Okay. Okay. So from utility, we can calculate marginal utility, which is just the change in utility going from one unit to the next. Technically speaking, it'll be the, if you know what this means, don't worry about it. Or if you don't know what this means, don't worry about it. But technically speaking, it'll be the derivative of the utility function at any particular point. 95% of you won't know what that means. That's fine. But really, it's just the slope of the tangent of the utility function. So those little yellow lines will give you the marginal utility. The slope of those will give you the marginal utility at each point. But for the purposes of this class, you're just going to take the utility from the second good minus the utility of the first good. And that'll get you the marginal utility of the second good. Okay, or if it's the marginal utility of the third good, you'd take the utility from the third good minus the utility from the second good, et cetera, et cetera. Okay. All right, then we have marginal benefit, which is highly related to marginal utility. I often use them interchangeably. Marginal benefit's a little bit broader because utility means something very specific. Benefit could be, it could be a profit benefit. It could be a utility benefit. It could be. It's just a broader term that doesn't. It's not as pinned down as utility. Okay, and then marginal cost is just going to be the change in costs going from the second good to the first good, or from the first good to the second good, or from the second good to the third good. So it'll just be the cost from the second minus the cost from the first will be the marginal utility or marginal cost of the second good. Okay. If you're confused on those, go back to the previous lecture. Those are important. You'll see them again and again. Even though this course is kind of running out of lectures, these are really key takeaways that you want to have nailed down when you go into further econs, and kind of a good takeaway for this class in general. Okay. All right, what's next? So, as I said, ignore sunk costs, make decisions using marginal analysis. All right, sorry, we covered that, so I'm not going to spend any more time on that. All right, and then the last, not the last point, but kind of the last point on this graph is an indifference curve. So an indifference curve maps all potential consumption bundles that give the same utility. Okay. So if I have an axis here, okay. Geez Louise, I need to take a drawing class. All right, so I have an axis here, and I have a consumption bundle. Let's say the consumption bundle is, on one hand, I have pizza. Let's say pizza's on the X here. Okay. And on the other, I have everything that's not pizza. Okay. So, that could be clothes, that could be movies, it could be new software, new apps, I don't know, whatever you spend your money on, a phone, okay? It's kind of a catch-all budget constraint here. Sorry, catch-all consumption bundle, okay? So let's just say that's everything that is not pizza on the y-axis, okay? So basically you have a consumption bundle of two goods, but one good is really many goods in this case, okay? It could be a consumption bundle of pizza and Mott's sticks if I wanted. Doesn't have to be though. Okay, depending on what the consumer's making a choice on, but I want them to make a choice on pizza and everything else. Okay. And just to refresh, I've been using the term consumption bundle. A consumption bundle is just a list of things that you consume in some sort of quantity. Okay, so one consumption bundle could be 1 pizza, 2 Mott's sticks, 4 shirts. Okay, 3 movies. Okay, that's a 1, 2, 3. That's a 4 good consumption bundle. Okay, so the utility function will be represented utility pizza, Mott's sticks, shirts, and movies, and we'd have some mathematical equation with 4 independent variables and 1 dependent variable. These are the 4 independent variables are the ones in parentheses. And if I gave you a math equation with 5 variables, you would kill me because you would need 4 other restrictions in order to come up with a good budget constraint on that, or in order to come up with an optimal budget or optimal consumption bundle. But we're not here. I'm not here to kill you with math more than I have to. So I'm just giving you the a 2 good budget constraint or too good utility function, utility pizza and not pizza. Okay. So the consumption bundle would be 1 pizza and we could say 9 not pizzas if we want to calculate it that way. And, because not pizza is not really a technical good, you probably want to put that in like a dollar form or something. So like your consumption bundle will be $3 or 1 pizza and $100 of not pizza. Okay. Just to have them all in the same unit. Okay. But you don't have to. It's really kind of open-ended how you construe your budget, your consumption bundles, depending on what kind of problem you're trying to solve. All right, but for the sake of it, just assume that there's not pizza and you can count your not pizzas 1, 2, 3, 4. Okay, and just humor me for this. Okay, so you have 1 pizza and not pizza. Okay. And even with only 2 goods in the consumption bundle, what are we going to have? Even with only 2 goods in the consumption bundle, we have a 3-dimensional utility function. Dimension 1, pizza. Dimension 2, not pizza. Dimension 3, utility. Okay. So if I wanted to represent that in 2 dimensions, I would use what we call a contour map. Okay. So if you ever seen like a map of the United States, and you have different altitude levels, and the different altitude levels are shaped or are colored differently. So high altitudes might be colored blue, and low altitudes might be colored red, and middle altitudes might be like purple or something like that. That's a contour map. It's a 2-dimensional map, but it shows you altitude as though it were 3-dimensional using colors. Okay. Similar to that, we can do the same kind of concept. We can apply that to an indifference curve. So we take the utility function, which is 3-dimensional on everything that's not pizza, and utility, and we're going to break it down into a 2-dimensional graph with utility as basically being the contours. Okay. So we can do it like this. Okay, where each level, each new color represents a different utility level. Okay. So that's your indifference curve. So you're still mapping 3 dimensions. You're mapping pizza, not pizza, and utility, but you're mapping it onto a 2-dimensional graph. Okay. So we could say this one utility equals 1, the black line. Utility equals 2, the orange. 3 at the purple. Okay. And 4 at the multicolor. Okay. So we're taking a consumption bundle, a list of all the things you're consuming. We're kind of pushing it down to a 2-dimensional graph. Okay. Now, I know I went through and had to explain why I'm using everything I kind of didn't explain why I'm using everything that's not pizza. The reason is because eventually I'm going to bring it back later in the lecture where I want to derive a demand curve for pizza. So I want everything that's not pizza to be represented as one unit. Okay. You could also have it as cash. Actually, now that I think about it, so cash and pizza could be your two goods, where cash can be a stand-in for everything that's not pizza. Should have thought of that earlier, but too late. All right. So a couple points I want to make. So we have the consumption bundles. They're typically increasing in utility as you go further up. Okay. So that was obnoxious to me to draw that graph for a second. Okay, so as I go further and further up, or northeast, as I go further northeast on the let's say as I go further away from the origin, utility generally increases in difference curves for higher utility. Okay, so the utility increases as they go further and further away from the origin. Reason is I like to consume pizza. So the more pizza I consume, right, the further to the right I'm going, and the more pizza I consume, the higher the utility. So as long as I'm going further right, I get a higher utility. Okay, and I like to consume things that aren't pizza as well. So the further up I go, the more things that I'm consuming that aren't pizza. Okay, so as long as I'm consuming more of those and I like those things, then I should get a higher utility. So as I'm consuming more pizza and more things that aren't pizza, I'm going to have a higher utility. So my overall indifference curve should increase in utility as I go further away from the origin. Okay. If for some reason I didn't like everything that's not pizza, I only ate pizza and I didn't do anything else with my life. I didn't wear shirts. I didn't, you give me a shirt, I say, oh, I hate this. You give me a mozzarella stick, I throw it on the ground. Okay. The only thing I do is pizza. Okay. Well, then the closer you are to the origin on the y-axis, the better. So basically your utility curve will be kind of sloped down, where you want to be as close to the zero on the y and as far from zero on the x-axis. Okay. So in that case, you probably have a indifference curve that looks like this or something like that. Okay. All right. So one other thing, the last point I want to note is that the shape of the indifference curve matters. So every point on this indifference curve is something that I'm indifferent about. Okay. So if I am at this point here or this point here, both points give me a utility of 1. Hold up, I'm going to stop for a second.